Metallic bonding is simply the bonding that you see in metals. So all of the blue boxes, that's the elements that are on the left-hand side of the periodic table of metals, and metallic bonding is just how, for example, atoms of sodium bond to atoms of sodium, or atoms of magnesium bond to atoms of magnesium. If we look at this example of sodium, these are lumps of sodium. And if you had a super-powered microscope, what you would see is that the bonding of metal is positively charged metal ions, which I've shown as these, which are plus, and they're surrounded by electrons. And these electrons are delocalized, they're free to move. So we say that the bonding in the metal is positively charged metal ions in a sea of delocalized electrons. Now, metals have a high melting point and a high boiling point. And one of the reasons for this high melting point and high boiling point is because there are strong forces between the positive metal ions and the negative delocalized electrons. Because positive attracts negative, negative attracts positive. And because these are strong electrostatic forces of attraction, you need lots of energy to break these forces. And because it requires lots of energy to break these forces, that's a high temperature needed, so metals have a high melting point. Metals conduct electricity, and for something to conduct electricity, there either has to be a movement of electrons or a movement of ions. In a metal, we know there are these things, these delocalized electrons, and these delocalized electrons are free to move. And because these delocalized electrons are free to move, metals conduct electricity. Metals are also malleable, which means you can bend them and shape them. And the reason why metals are malleable is because the layers of positive metal ions can slide over one another.